Welcome back. Yesterday we have started the discussion on permutations. I'll just quickly go through what we did yesterday, and then we're going to take many more sums on permutation. Okay. And yes, good afternoon, Pooja. Right. Okay. Okay, so we said that permutation is the manner in which you are arranging the things that are there in your group. Okay. Now, we talked about what? We have talked about factorial, right? We've talked about factorial. So, what is n factorial? N factorial is 1 into 2 into 3 into 4. And up to where will it go? N minus 2, n minus 1 and n. Or we can also write it in the reverse order. So n, then 1 less than n is n minus 1. 1 less than n minus 1 will be n minus 2 and so on. We will go up to 1. Okay. So the simple ones that you should know is 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, 7 factorial is 75040, 8 factorial is 40320 and so on. Now you must remember this also, that it helps while solving the problem, that I can write 4 factorial is 4 into 3 factorial. Okay. That is n factorial can be written as n into n minus 1 factorial. Okay. So some of you were asking, so this n factorial is for this n minus 1. Okay. I will use a different color and show you. So n factorial is equal to n into, this is n minus 1 factorial. Okay. So this n minus 1 and factorial are together. So similarly, 7 factorial can be written as 7 into 6 factorial. So how much will this be? 7 into 720. So which brings us to, this is equal to 5040. So once you remember 5 factorial, okay, so just remember 5 factorial is 120. So bigger numbers, if they come also, you will be able to do them quickly. Okay. Then we did this sum, simple sums. We found out the value of x. And here we use this property. Okay. We use this property, n plus 1 factorial is equal to 30 into n minus 1. So we use this property, n plus 1 factorial can be written as n plus 1 into n minus 1. Okay. So here we have used this property here. Okay. N plus 1 factorial can be written as n plus 1 into n minus 1 factorial. Okay. Then we talked about the two fundamental principles of counting. One is the multiplication principle and second is the addition principle. What does the multiplication principle say? That you do a certain thing in m ways, and then after you have done that, you do another thing in n ways. Then the total number of ways in which you can do the things is m into n ways. Okay. So here what we are saying is, first thing can be done in m different ways, and when that thing is done, the second one is done in n ways, then the total number of ways. Okay, so total number of ways in which both the things can be done simultaneously is m into n ways. Okay. So we discussed this example of a child wanting to go to school. What are the bus routes available to him? And once he goes to school and once the school finishes, how he comes back. Okay. What does the addition rule says? That if one job can be done in m ways and the same job or an alternate job can be done in n ways. So then we say that the total number of ways in which either of the jobs can be done is m plus n ways. Okay. I repeat, if one job can be done in m ways and an alternate job can be done in n ways, then either of the jobs can be done in m plus n ways. Okay. So, like when we are talking about the example of the student going to school, we can say that the student can go to school either by bus or by an auto, and so he has this option. So, if he goes by bus, how many different ways does he have? If he goes by auto, how many different ways can he go? And then together that he will be able to reach from his home to the school in how many ways. Okay. So we said that permutation is a way of arranging the objects in a group. So these are the two ways in which you can represent the factorial, represent the permutation. So we have the two ways are NPR is equal to n factorial upon n minus r factorial, which you can also write this as equal to n into n into n minus 1 into n minus 2. Till where will we go? We will go up to n minus r plus 1. Okay. So up till there we can go. So which formula will I use? It will depend on whichever sum we have, we will be using that. So whatever is useful for that sum, we will be using that formula. But there you have a choice, because it's an MCQ exam, you can use whichever formula it is suitable to you. Okay, these are very important. NPR we already know, we have written. Remember to apply BODMAS, so that you have to solve the bracket n minus r first and then find the factorial of that amount. Okay, that number. 0 factorial is always equal to 1. You can get this as a direct question also, or indirectly you may need to use it. NPN, when if we have, what does NPN mean? That if I have n objects and I select all the n objects and arrange them. Okay. What NPN means is I have n objects, and from the n objects I select all the n objects and then I arrange them. Okay. So then how much will that be? This will be equal to n factorial. So suppose 5 students are there and you want to arrange their students for a photograph, then if I select all the 5 students, then it is NPN. So out of 5 students, I am selecting 5. So it is NPN. So that is n factorial. What happens if out of 5 students, I only pick up 3 students and I arrange them for a photograph? Then it is 5p3. Okay. So here, let me tell you once again the significance of n and r. So what does n? N is the total number of objects in the group. And R is the number we are selecting for rearrangement. Okay. So what does NPN says? For example, 5p5. Okay, 5 students. I take all the 5 students and make them stand for a photograph. Then in this case, this is also N5 and this is R. Okay. What if out of 5 students, I ask only 3 students to come up? I ask 3 students to come and I make them stand for the photograph. Then in that case, we will write it as NP3, where this 5 will be the N and this 3 will be the R. Okay. Then this we already know, n plus 1 factorial minus n factorial is equal to n star n factorial. Okay. Just let me show that to you again, because these are very important formula that you need to use, because sometimes you have understood the question well, but execution you may have an issue. So let us see. Okay, so what do I have? I have this we are discussing. Okay, we are discussing this. Let me increase the size of the pen. So my sum says I want to find out n plus 1 factorial minus n factorial. I want to simplify this. Now n plus 1 factorial can be written as n plus 1. I subtract 1 from this. So this will become n. Again, I subtract 1 from this. So this will be n minus, or we don't even need to go up to there. Okay. We're just writing this as, this is a simpler one. Okay. This is n plus 1 into n factorial. Okay. Minus n factorial. Now I take n factorial common. So this is n factorial. What will remain? This is n plus 1. Now from this I have taken out n factorial. So what will remain? 1. So minus 1. So plus 1 minus 1 will get cancelled. So this will be n factorial into n, which is usually written, the number is written first and the factorial later, n into n factorial. Okay. Okay, then we did a lot of sum. Let me check. Yes, Anshu, this is the only way to correct. You can post questions over there. Any queries, you can even mail. The institute will answer for you. Yes, yes, Gunchita, Rohini, Devjit, Ritika, Sarvesh, Zeba, Rohan, yes, Rafika. Okay, Sejapreet, you want 7th sum? Example 7 or question number 7? Yes, Murtaza, I'm good. Thank you. Example 7. Okay. Yes, Himanshu, correct. He's saying that if I'm selecting 4 people from 5 people, what will happen? Okay. Yes. Let us talk about that also. So he's saying that out of 5 people, if I'm selecting 4, what will happen? So this is 5 factorial upon 5 minus 4 factorial, which is 5 factorial upon 1 factorial, which is equal to 5 factorial. Why this happens? Because out of 5 people, when I have already selected 4, the remaining person will automatically be placed in the last position. Okay, so if I'm trying to arrange them in a photograph, 1, 2, 3, 4, 5. These are the 5 places I want them to stand. Okay, then I have children A, B, C, D, E. Okay, I ask E to stand here. So he stands here. Then I ask B to stand here. So B stands here. Sorry. Then B stands here. Then A stands here. Then I say, okay, D, you stand here. So D stands here. Okay. Now what happens? Automatically for C, I have this place already fixed. There is no other way. So what happens is, this is the way we are able to get the answer. Extreme left part is not visible. Okay. Take support. हेलो, हाँ बच्चे बोल रहे हैं लेफ्ट का दिख नहीं रहा उनको. कर दिया जी, थैंक यू. ओके, यस. Yeah, I hope you can see the screen now. Yes, good. Now let us go to this sum. Seventh sum. Just let me check. Seventh sum, this is the only number of factors is equal to r. So you just have to count, okay? You can do that like if I'm saying 5 factorial, okay? They're asking in NPR, what will be the number of factors? Okay. Let me show you. Suppose I have 7p2. How will 7p2 be written as? 7 factorial upon 7 minus 2 factorial, which is equal to 7 factorial upon 5 factorial, which is equal to 7 factorial. I will write up to 5 factorial. So this will be 7 into 6 into 5 factorial upon 5 factorial. So 5 factorial will get cancelled. You have 7 into 6. So if 7p2 is equal to what? 7 into 6. How many factors are there? 7 is one factor. 6 is another factor. So number of factors is equal to 2 here, which is nothing but r. Okay. Here what is happening? N is equal to 7. R is equal to 2. Right. So what are the number of factors? It is equal to 2. Okay. This is simply that. Just take any example. You may even take 6p3. Okay. So 6p3 will be 6 factorial. 6 minus 3 is 3 factorial. This is equal to 6 into 5 into 4 into 3 factorial. Okay. Upon 3 factorial. So this 3 factorial will get cancelled. You will be left with 6 into 5 into 4. Okay, 1, 2 and 3. So number of factors is equal to 3, which is equal to r. Okay. Okay, now let us do this 12th sum. Okay, Sakaldeep, I will see which example you want. I will see and I'll let you know. Okay. Now let us do the other sums now. Now this is a 12th sum from exercise. If 5pr is equal to 60. If 5pr is equal to 60, then the value of r is 5pr. I know that npr is n factorial upon n minus r factorial, right? So 5pr is equal to 60. Now let us put the options also. So first option is equal to 3. So 5p3 is how much? 5 factorial upon 5 minus 3 is 2 factorial, which is equal to 5 into 4 into 3 into 2 factorial, upon 2 factorial. So this 2 factorial will get cancelled. 5 2s are 20, 23s are 60. Okay. So what is the answer? This is A is the answer. Now let me show you the method also. This is 5PR can be written as 5 factorial upon 5 minus R factorial, which is equal to 6. How much is 5 factorial? We know that 5 factorial is 120. So 120 is upon 5 minus R factorial is equal to 60. So I have 5 minus R factorial. Okay, I cross multiply. I take 5 minus R onto the top and 60 down. So this becomes 120 upon 60. So 5 minus R factorial is equal to 2. Now let me check. How much is 1 factorial? 1 factorial is 1. 2 factorial is how much? 1 into 2, which is equal to 2 factorial. Okay. I want a number whose factorial is equal to 2. So which is this number? 2 factorial. So 2 is the number whose factorial is 2. Okay. So I have 5 minus R factorial I know is equal to 2. That means this number. Okay. This means this number in the bracket is equal to 2. So this means 5 minus R is equal to 2. So I have R to be equal to 5 minus 2, which is equal to 3. So R is equal to 3. Okay. So I have shown you both methods. In this first method, I just take what the options are there. I will quickly put it in NPR, find the answer. Okay. If in case you would like to know how to do it, this is the method to do it. I have come to this stage. This step is very important. Okay. I have to find a number whose factorial is equal to 2. So I know from that 1 factorial is 1, 2 factorial is 2. So 2 factorial is equal to n minus R. And then I solve, I get R is equal to 3. Okay. Okay, you are asking for the 15th question? Yes. So that's what I said. Understand as far as possible. I have chosen all the sums that are useful to you and that are different. Okay, now what has happened here is okay. Now let me, whenever you have this question, let us read the question. The number of arrangements of the letters in the word failure so that the vowels are always coming together. You know which are the vowels? Which are the vowels? A, E, I, O, U. All other alphabets? All other alphabets equal to are called as consonants. Is that clear? So I have this. Now I will read this, let this word failure. So if it is a consonant, I will write it here. If it is a vowel, I will write it here. Now failure F. F is a consonant. A is a vowel. I is a vowel. L is a consonant. U is a vowel. R is a consonant and E is a consonant. Oh, E is a vowel, sorry. E is a vowel. Okay. So these are my vowels and these are my consonants. So how many consonants do I have? 3. How many vowels do I have? 4 in the word failure. Okay. So what they are saying is you have to pay attention to the condition that they have put. What is the condition? Vowels are always coming together. Okay. So that means I have to rearrange the words, letters in the word such that I have F, I have L, I have R, but I have this box which contains R, A, I, U, and E. Okay. So what this means is how many letters do I have? 1, 2, 3, and 4. Okay. And how many letters do I have to select? All, because there is a number of arrangement of the letters. So this is what? This is as good as P, 4P4. Yes. 1, 2, 3. This is my first alphabet. Okay, just let me change the color. Okay, this is my first letter. This is my second letter. This is my third letter. And this is my fourth letter. Okay. So 4P4. Now, but within this AIOU, AIUE, I can rearrange them in how many ways? 4 factorial ways. Okay. So this into 4 factorial ways. Now, how much is 4P4? You know, NPN is equal to n factorial. So 4P4 is how much? 4 factorial. And this 4 arrangement of the vowels within themselves is equal to 4 factorial. 4 factorial I know is 24 into 24, which is equal to 576. Okay, so answer is 576. First, in this question, I have to first separate the consonants and the vowels. Once I have separated them, what do I have to do? I have to take the vowels together. So I consider this as good as one letter. Okay, all the 4 vowels that I have in the word failure, I consider them as together. And then I arrange the 4 letters, and the 4 vowels also I can arrange them themselves in between. Okay, see, like I can have A-I-U-E or I can have I-U-A-E. Okay, so many different ways. How many different ways are there? 24 different ways, because it is equal to 4 factorial ways in which I can rearrange the vowels. So that is why the letters in the word F, L, R and this vowel is taken as 4P4, and within the vowels it is 4 factorial. Okay. Yes, Nital, very good. We Harnoor, because there are 4 vowels here, that is why we are multiplying by this 4. Okay, how many vowels are there here? 1, 2, 3, 4. These are the vowels in the word failure. So we are using 4 factorial. Okay, that is why we are multiplying. This 4 factorial is because there are 4 vowels in the word failure. Okay. Now 10 examination papers are arranged in such a way that the best and the worst papers never come together. Okay. Now, if I have no condition, how will I arrange 10 examination papers? 10 exam papers can be arranged in 10p10, which is equal to 10 factorial ways. Now what is happening is I have the best paper. One is the best paper. Then I have paper 1, paper 2, paper 3, paper 4, and up to paper 8. And then I have the worst paper. So I have 10 papers, 1, 2, 3, 4, 5, 6, 7. And let me write them down. P5, P6, and P7. So how many papers do I have? 10 papers. One is the best paper and one is the worst paper. So that they never come together. So what they feel is that the paper should not be arranged in such a way that I have B, then I have W, the best paper, the worst paper together, and then I have P1 to P8. They don't want this condition. Okay. So what we do is we will first find what will happen when they are together. What is the total number of ways in which I can arrange 10 papers? 10 factorial ways. In how many ways can I arrange those 10 papers in such a way that the best and worst papers come together? We will find out. Then from the total number of ways, I will subtract the ways in which the 10 best and the worst paper are together. Then I will get the condition where the papers are arranged in such a way that the best and the worst papers are never together. Okay. Okay, so then exam papers can be arranged such that the best and worst paper are always together is how much? So I have 8 papers, P1 to P8. Then I have the best paper and the worst paper. Okay, best paper and the worst paper. These two are taken together. So P1 to P8 is 8 papers and this is 9 papers. So this is 2 factorial into 9 factorial. Okay, why 2 factorial? Because I can have papers worst and best, or I can have the best paper first and the worst paper after that. Okay, so these are the two options, worst and best, and or best and worst. So this is the case. So 2 factorial into 9. When I subtract this, so 10 exam papers arranged in such a way that best and worst are never together. So 10 factorial is the way in which I can arrange all 10 papers without any restriction. Then I put the restriction that best and worst should always be together. So from the overall, all papers can be selected without any restriction. Minus this restriction will give me the answer to my question, that arrangement of 10 papers in such a way that the best and worst papers are never together is equal to 10 factorial minus 2 into 9 factorial. Now 10 factorial, I can write it as how much? 10 into 9 factorial, right? Because I know that n factorial can be written as n into n minus 1 factorial. This is the formula I have used over here. N factorial is equal to n minus 1 factorial. So this is equal to this minus 2 into 9 factorial. From here, I take out 9 factorial common. Okay. This 9 factorial and this 9 factorial I take out common. So this is equal to 9 factorial 10 minus 2. So this is equal. 10 minus 2 is 8. So it is 8 into 9 factorial. So option C is the correct option. Okay. 10 exam papers can be arranged unconditionally in 10 factorial ways. I put the condition that the best and worst papers are always together. Why I did that? Because the question is asking me when they are not together. So from this whole, I am subtracting the papers in the conditions in which both these papers are always together. So once I eliminate that, what will remain is the condition that is satisfying, is the number of ways in which the condition is satisfying that the best and worst papers are not together. Okay. Now let us go to the 19th sum. Ritika, why 4P4 in the earlier sum? Tell me. There are 4 and I want to select all 4. So 4P4. Okay. Out of 4, I am selecting 4 because what in the earlier sum I had done? That F is taken as 1 letter, L is taken as 2nd letter, R is taken as 3rd letter, and all the vowels together are taken as the 4th letter. So 4P4. Yes, Avdesh, that is the correct answer. 10 factorial minus 2 into 9 factorial. But we have to simplify because you will not have this as an option. You will have, see, in the option, did you see? We don't have this answer. Okay. So what I have to do, I have to simplify it further. No, Srinidhi, this is the only way to solve it. You have to follow what is correct, you know. So there may be some printing mistake somewhere, but now their institute has taken into it that every study material has been thoroughly revised. Okay, so usually we don't have this problem. No. Yes, Rohan, I have already uploaded the presentation, right? Okay. Now this sum you have to be careful because very rarely they ask such type of sum, but you must know the sum of all 4 digits. Normally they will ask you how many digits are found, how many numbers are found. Okay. So, but here they are asking the sum of all 4 digits. Okay. Of all 4-digit numbers containing the digits 2, 4, 6, 8. Now here what happens is, we have a 4-digit number. I hope you know the basics. Suppose I have a 4-digit number. This is my, let me see. 1, 2, 3, and 4. This is my 4-digit number. This is called as units place. This is called as the tens place. This is called as the hundreds place. and this is called as the thousand place, right? So if I write suppose 8 over here, what does this mean? And if I don't write anything over here, that means this is how much this stands for 8,000, right? 8, if you've written in this place, it just means 8,000, right? So its value is 8,000. If I write say 6 over here, this is 600, okay? Because I'm writing it in the third place, it is 600. So here, how much will this be? 6,000 plus 600. So it gives me 8,600. Okay. If I write 2 over here, so what does this mean? This means it's 20. So I already had 8,600. With that, I have 20. So this becomes 8620. What if I write 4 over here? This is in the units place. So it is the value 4 only. So this is 8620 plus 4. So the number is 8624. Okay. So this is a basic understanding that you must know when I'm showing you the explanation for this, that in what position that number is placed, it is going to carry that value of that position. Now, because there is 4-digit number, now I suppose fix this number as say 8. Suppose I put 8 in the first place over here, that is in the thousands place. How many places are remaining? 1, 2, 3. Okay, I have to fill 3 places. How many digits are remaining? See, because I had 2, 4, 6, 8. So out of 2, 4, 6, 8, I have already taken 8. How many digits? 3 digits. How many places? 3 places. These can be arranged in how many ways? That is 3p3, which is equal to 3 factorial. Okay. So for 8, if I fix 8 over here, okay. So if I fix 8 in the thousands place, I will have how many numbers which will start with 8? That is 8,000. How many numbers? So this is 3 factorial numbers. Okay. So what will happen? This is equal to 3 factorial. Then I can have 6 over here. So how many, if I in the first place, if I fix 6, how many numbers will I have? Again 3 factorial, because 3 places, 3 numbers. If I fix 4, what will I have? 3 factorial. If I fix 2 in the first place, that is in the thousand place, how many will I have? 3 factorial, because 3 places, 3. Now, if this is in the thousand place, I have 3 factorial, so on and so forth. So you may have fixed 8 in the thousands place, or you may fix it in the hundreds place, or you may fix it in the tens place, or you may fix it in the units place. How many of these will you have? You will have them as 3 factorial. So 3 factorial ways, numbers are there in which you can have this arrangement. Okay. Just write this. This is equal to how much? 8,888. Okay. How many do I have these? So I have 3 factorial. Numbers are there in which the sum of the numbers of which you have the how many of such numbers are there? There are 3 factorial ways. So similarly for 6, if I put 6 in the thousand place, it will be 6,000. Then 6 in the hundred place, it is 600. 6 in the tens place, it is 60. And 6 in the unit place, so this is 6, 6, 6, 6. Similarly for 4, it is 4,000 plus 400 plus 40 plus 6 plus 40 plus 4, sorry. So this is 4, 4, 4 and 4. So 2 is 2000 plus 200 plus 20 plus 2, which is giving me 2, 2, 2, 2. So what is the total? 8888 plus 6666 plus 4444 plus 2222, which is equal to 22220. And how many such numbers are there? 3 factorial ways. How much is 3 factorial? 6. 2222 into 0 into 6. So into 6, how much is this? 13332. Okay, so A is the correct answer. In this sum, I have 4 digits, 2, 4, 6, 8. I want to arrange them in such a manner that there is no restriction. Okay, I can arrange them. But what does the sum want? The sum wants you to find out the sum of all such 4-digit numbers. So what will happen? Either, like for example, I'm taking the number 8. If I fix the 8 in the thousands place, I will have 3 factorial. So there will be 6 numbers which will have the first digit as 8. Okay, let me show you for 8. Okay, just let me show you for as an example. Suppose I fix 8 in the thousand place. Okay, what will be the options I have? 6, 2, 4, 6. Okay, this is one number. Then 8, I can have 4, 6, 2. I can have 8, 6, 2, 4. I can have 8, 2, 6, 4. I can have 8, 4, 2, 6. And I can have 8, 6, 4, 2. Okay. Can I find out this? That if I fix 8 in the first place, how many numbers do I have? 6 numbers I have. If I fix 6 in the thousands place, I will again have 6 numbers, and so on and so forth. Okay. So, and when I add these all up, I am getting this answer. Next question. The number of 4-digit numbers greater than 5000, which can be found out of the digits 3, 4, 5, 6, and 7. Okay. So what are the digits with me? I have 3, 4, 5, 6, 7. What is the condition? Number should be greater than 5000. Okay. So you should be careful that you're following what you're paying attention to what the information is given. Okay. Now, how many digits do I have? 1, 2, 3, 4, 5. Normally, what would have happened? Their N is how much? 5. R is how much? 4. Why 4? Because I want to form a 4-digit number. I would have written 5P4 and I would have got this as 5 factorial. That is, I have 120 numbers from 5-digit numbers I have. But the condition is that the number should be greater than 5000. So that I have to find out this. 1, 2, 3. Okay, 4-digit number. This is which? This is the thousands place. Okay, in the last sum also we discussed. This is the thousand place. Which are the numbers you can have here? Because my condition is what? It should be greater than 5000. So numbers can be what? 5, 6, and 7. Can I write 3 over here? No, I can't, because then it will be 3000. But I want the number to be greater than 5000. So I can have 5 over here, 6 over here, or 7 over here. Now what will happen over here? What can I do in this place? 3 places. And how many numbers do I have? I will have 4 numbers. So this is 4, 3, 3. Because, for example, 1, 2, 3, 4. I fix 7 over here. Then what will remain after 7 has gone? What are the digits that are available? 3, 4, 5, and 6. So out of these 4, but how many places you have? This is 1, 2, 3, 4. How many places you have? 1, 2, 3. So then it is P4, P3. Okay. So how much is 4P3? 4 factorial. And how many numbers can I select from here? 3P1. Okay. So how much is 3P1? 3. Okay. So this first position is 3P1. For this, I am going to rearrange by using 4P3. So this is 4 factorial into 3 factorial. So this is 24 into 3, right? 24 into 3, that is 70. Okay. I again repeat it for you. I have 4 places, 1, 2, 3, 4. In the 4 places, I can only have the numbers 5, 6, and 7. Why so? Because the number has to be greater than 5,000. So I have here the selection of one digit from 3 digits. I have 3P1. What happens over here? Once this is selected, I can select 3, 4, 5. Okay, and one of these and one of these. So I have 1, 2, 3, 4. Okay. So how much do I have over here? This is 4P3. So this is equal to 3 factorial 3 into, not 3 factorial. Okay, yes, that's what I said. What is wrong here? This is 24 into 3, not 3 factorial, only 3. How much is 3P1? 3 factorial upon 3 minus 1, that is 2 factorial. Into this is how much? 4 factorial upon 4 minus 3, that is 1 factorial. 3 factorial upon 2 factorial gives me 3. 4 factorial gives me 24, which is equal to 3 into 24 is 72. Okay. So this is the answer. So here you have to see what numbers I can use over there, and then accordingly I have to use. Okay. Because what has happened here is I have taken one number and the other will be available. Okay. Yes, sorry, no, in the 19th, it is not A, it is D. Yeah. Thank you for pointing it out. Yes, Masum, Prayag, 133320. So, because this is 20, this number has 1 4 times 3, 0. This is 133320. Yes, thank you so much. What question? Okay. Now this is also a very interesting sum. What will happen over here? There are 4 digits are to be found out of the figures 0, 1, 2, 3, 4. Okay. 0, 1, 2, 3, 4. This is a special case. Whenever you have 0, you have to be very careful. Okay. Because 0, if it is on the most left hand side, it will have no value. That is why you have to be very careful with this step. Then the number of such numbers is 4-digit number is to be formed. Okay. So 4-digit number 1, 2, 3, 4. They are not put any other condition. They are just saying that it has to be a 4-digit number. What will be the numbers which I can use over here? I can use 1, 2, 3, 4. Can I start a number with 0? No, it will be of no use. If I write 0 over here, suppose I write 0, 4, 3, 1. What does this mean? This is 431, right? Which is a 3-digit number. Okay, because I have put 0 on the most left hand side, which is not allowed. Okay, because why it is not allowed? Because I want all numbers to be 4-digit number. Had they put no restriction, I could have considered. But since they have put the restriction, already put the restriction, I will have to use it accordingly. Okay. So out of this 4, I want to select 1. So what will this be? This will be 4P1. This will be 4P1. Once I have selected one number, suppose I selected 3 over here. How many will be here available? Now for these 3, suppose I have written 3 over here. Okay, my 4-digit number is starting with 3. Then for what will be the numbers available? Here I can write 0. In this, I can write a 0 here. So 0, 1, 2, and 4. Because I have 3 already placed it in the thousands place. So 4 numbers are there. 4 digits are there. How many should I select? 3. So into 4P3. So number of 4-digit numbers is equal to 4P1 into 4P3. 4P1 is 4 factor. Four factorial upon 3 factorial into 4 factorial upon 4 minus 3, that is 1 factorial. Okay. 4 factorial upon 3 factorial is 4. 4 factorial is how much? 24. 24 into 4 will be equal to 96. So C will be the correct option. Is that clear? Here I have to be careful with the 0. In the first place, I cannot have 0. So I have 1, 2, 3, 4 only. So remaining, and in this case, in the remaining all places, I can have a 0. Okay. Now we did the sum on vowels. Okay. There what happens? We kept the vowels together. Similar, this sum is similar to that sum, but only here they have taken the word, part of the word and kept it together. Okay. So it is same that way. Okay. Now I have T, R, I, but what they are saying, arrange in such a way that the alphabets at angle will always remain together. So I will write this as A, N, G, L, E. So effectively, how many letters are there? Effectively, how many letters are there? 1, 2, 3, 4. So it is as good as 4 letters. The number of ways in which you can arrange 4 letters into words okay, will be equal to how much? 4 letters is 4p4 into. What about arranging the letters within angle? What about words within angle is? Okay, so that the word angle will always be present is 1, 2, 3, 4, 5. So I have this. This is always going to be together. So 1. So 1, 2, 3, 4. So it is 4 factorial upon 4 minus 1. 4 minus 4, that is 0 factorial, which is equal to 1. So 4 factorial. Answer is 24. Why? Because they are saying angle will always be together. Angle will always be there and it will always be together. So it should be taken as one alphabet and the remaining remaining alphabets you have. Okay. Now we have this letters of the word daughter. The letters of the word daughter are to be arranged so that vowels occupy the odd places the number of different words are. Okay. Now, like we did in the earlier sum, I'll show you. Okay, in failure, what we do? We showed the consonants and we found out what the vowels were, and then we proceeded further. So same thing we are going to do over here. Okay, so daughter. Let us see which are the consonants and which are the vowels. Now D, whether it's a consonant or a vowel, it is a consonant. A, vowel. U, vowel. G, consonant. H, consonant. T, consonant. E is a vowel and R is a consonant. 1, 2, 3, 4, 5 consonants and 1, 2, 3 vowels. How many letters are there in the in the word daughter? 1, 2, 3, 4, 5, 6, 7, 8. Be sure that you check this. So there are 8 letters in the word daughter. How many out of these 8 letters? 5 are consonants and 3 are vowels. Okay. So they want vowels to occupy the odd places. So 1, 2, 3, 4, 5, 6, 7, 8. This is what position 1, position 2, position 3, position 4, position 5, position 6, position 7, position 8. So where can you place the vowels? I can have the vowels here, 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 and here. So I have 4 places in which I can put the vowels. Why that has happened? Because the condition is that the vowels will always stay in the will always occupy the odd places. So 1, 2, 3, and 4. So it is going to always occupy the odd places. So I have 1, 2, 3, and 4. Which are the odd places? First place, third place, fifth place, and seventh place. So vowels can be arranged in 4P. There are 4 positions available. How many vowels are there? 3 vowels are there. What about consonants? How many places do I have? After one has been occupied, how many places will I have? 1, 2, 3, 4, 5, 6, 7. Okay. Because one place has already been occupied. So I will have 7 places, and out of the 7 places, I will have 5. 1, 2, 3, 4. 5 consonants have to be placed. So this is how much? 4p3 is how much? 4 factorial? And how much is this? 7p5 is equal to 7 factorial upon 2 factorial. 7 minus 5, that is 2 factorial. This is 4 factorial upon 4 minus 3, that is 1 factorial. This is equal to 4 factorial into, this is going to simplify into 7 into 6 into 5. Okay. So just let me show this. I don't have enough place over here. I'll just write it here. Okay, so this is equal to, vowels will be occupying 4 factorial and this is going to occupy how much? 7p5. Okay, so I will have, how much is 4 factorial? 24. So I will have just write it from the left hand side so that it becomes easier for all of us. Okay. So out of these places, I have how much? For the vowels, which are the position? For the, start from here. For the vowels, which are the position that I have? P1, P3, P5 and P7. How many vowels are there? 3. So I have 4p3. Okay. Now consonants, which are the positions that I have? P2, P4, P6 and P8. Okay. And the remaining are, out of this, whichever is available. So I have those numbers also. Okay. So I have consonants will occupy P2, P4, P6 and P8 and not occupied by vowels. Okay. Because out of these 4 places, 1 place has already been, 3 places have already been occupied by the vowels. So what are the remaining place? Only 1 place remains for the consonant. So suppose what happens, P1, P3 and P5. I use A, U and E. How many places are remaining? Odd places. Only P7 is remaining. So only P7 will have come here. So 1, 2, 3, 4, 5. So how many are there? 5 places are available. And how many consonants are there? 5. So I have vowels and consonants. So this is 4p3 into 5 into 5p5. Okay. Because there are 3 vowels. All the 3 vowels will occupy places. Then you will have one odd place which is available for the consonant. So 4p3 is 4 factorial upon 1 factorial. 5p5 is equal to 5 factorial upon 0 factorial. So this is equal to 4 factorial 24 into 120. So how much will this be? 24 into 120. Answer is 2880. Okay. So I will explain this again. There are 8 places. Out of these 8 places, 4 are odd, 4 are even places. My vowels will only occupy the odd places. So out of these four odd places, three are occupied by vowels. So one odd place is available for the consonant. What are the even places? Four even places plus this one odd place. So I have five places available for consonant. Out of these five places, how many consonants do I have? I have five consonants. So 5 places for 5 consonants. In how many ways I can do that? That is 5 factorial ways, because 5 upon 0 factorial is 5 factorial. What about the vowels? There are 4 places for the vowels and only 3 are occupied by them. So this is 4p3. So you have 4 factorial upon 1 factorial into 5 factorial upon 0 factorial, and you get the answer as 2880. Clear? Yes, Kushdeep, I have repeated. Hope you have understood. Here. Okay. Let's use another pen so you'll understand. There are 8 places. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 8. Out of these 8 places, vowels can occupy 1, 2, 3, 4, 5. 1, 2, 3, 4. Out of these 4, how many vowels are there? 3. So 4p3. So 3 vowels can occupy 4 odd places in 4p3 ways. What about the consonants? These are 1, 2, 3, 4 and not occupied by vowels. So only one position is not occupied by vowels. So there are 5 places available for the consonant. How many consonants do we have? We have 5. So 5p5. Okay. Now coming to what is the circular permutation. Now what happens is, up till now we are talking about arranging these people, goods in a linear manner. So one person is standing to the left and in the center, then somebody at the end. So it was a linear way. But you also have arrangements where you are seating people in a circular way around a round table. So how do we do that? So is there any formula to find out about circular permutation? Let us find out. So suppose here I have this. I have 4 people, A, B, C, D. If I fix the place for A here, and then what will happen? I can have A, B, C, D. Okay. Then what I can do is I can shift. So I shift A onto this side in place of B. So A sits in B place, B sits in C place, C sits in D place, and so on. Okay. So this way you can have, or you can have on the left hand side. Okay. I ask them to shift chairs. So A, who was sitting over here, goes to this side, to left, and then A. Then this is not A, this is B. This has to be D, and this has to be D. So if I'm moving in this direction, then it is A, D, B, C. So what happens here is, or I can flip this instead of B to D. So I can write D over here and B over here. Okay. I'm fixing places A and B, and then I have this. So what will happen in this case is, this is known as circular permutation, where people are occupying in a circular place, and then you may have the same namers or you may not want to have the same namers is the second condition. So here there are NPN upon N ways in which N things can be arranged in a circle. Very important. There are NPN upon N ways in which all N things can be arranged in circle. So here what happens, have you noticed over here? In this example, who are the neighbors of A? Those are B and D. Who are the neighbors of A, B and D? What happens over here? A is again having B and D as his neighbor. Okay. So we want to avoid that. If you want to avoid that, then they are saying that the number of ways of arranging N persons along the round table so that no person has same two neighbors is given by 1/2 into N minus 1 factorial. Is given by 1/2 upon into N minus 1 factorial. Now this is when people are sitting. So people, you are able to identify X from Y, okay? But what happens when you don't have this, when you are not able to easily identify? Suppose I take a necklace, okay? I take a necklace with beads which are of the same color. Will I be able to find out whether I'm looking at the front of the necklace or at the back of the necklace? No, because all the beads are similar. But what happens in a round table when they're sitting, people are sitting, yes, I am able to identify people. But so what they do is that, and then when we have this condition that they do not have the same two neighbors, this is equal to 1/2 N to N minus 1 factorial. Similarly, in forming a necklace or a garland, what do we have? The number of necklaces formed with N beads of different colors is given by 1/2 into N minus 1 factorial. Then coming to permutation with restrictions. Yes, good Srinidhi, Abhinav, Jabba. Yes, Bhagdevi. Yes. Yes, Diksha. Isha. Okay. So here we have talked of circular permutation. So when I want to arrange people around a table in such a way that no two same, the person does not have same two neighbors, it's 1/2 into N minus 1 factorial. When I have number of necklaces formed with N beads of different colors, I have 1/2 of N minus 1 factorial. Then we have permutations with certain restrictions. So what can that be? Permutation with restrictions are number of permutation of N objects taken R at a time when a particular object is not taken. When a particular object is not taken in any assignment. Okay. So since a particular object is always to be excluded, we will place N minus 1. So instead of N, I had, say, suppose 5 balloons. And I'm saying, no, that yellow balloon, I'm going to keep it for myself. So what will happen? Everybody else will have to choose from the remaining balloons, isn't it? So how do I do that? Is I will write it as N minus 1 PR. Okay. Why? Because from the superset, I have taken out 1. So what are remaining is N minus 1. Okay. Suppose I have 10 toys. Okay. I have taken 1 toy for myself. How many toys will be left? 9 toys will be left. And from then I have to select, say, suppose 5 students. I want to give toys to 5 students. So earlier with no restriction, it would have been 10 PR. But because there is a restriction that I will not give this toy for distribution, so in that case, it will be 10 minus 1, which is equal to 9. So 9 PR. We will just take a 2 minutes break, tech support. Yes, just give me 2 minutes. Yes. Welcome back. Okay. So number of permutations of R objects out of n distinct objects when a particular object is always included. In the earlier one, we are saying when a particular object is not taken in any arrangement. Suppose I have this, I have numbers 2, 3, 5, 7, 9. What if I say that 2 is never taken? Then what will the number of objects available to me be? 3, 5, 7, 9. Okay. So what? How many numbers were there before? I had 5. So n was 5 over here. Now how much are there? 4. So this is what? N minus 1. Okay. This was the case when I had taken when one number or one object is always excluded. So I take n plus 1 PR, n minus 1 PR. Now it is the other thing that they are saying that whenever you're selecting, you have to select one. That one object has to be there every time. Okay. Then the number of permutation of n r objects out of n distinct objects when a particular object is always included is, what will happen is, in the earlier one, I had n minus, remember, n minus 1 PR. Now the number, now this formula changes to n minus 1 P, because one object is always taken, P R minus 1. Here what will happen? The R is going to change. N is also changing, but here R is also changing. Suppose, as I said, I want to form a four-digit number, 3-digit number. So, okay. And I have the numbers 2, 3, 4, 5, 7. What will happen is, if I say 2, the number 2 has to be always present. So, suppose I will fix 2 over here. What is available for these two? I have already selected this. So earlier n was 5, now n will become what? N will become 4. How many places are available? Only 2 places. Earlier R was 3. Okay, 1, 2, 3. But now R has also become 2. 3 minus 1, 2. Why? Because only now 2 places are there. I have to rearrange. So you may get this as a theory question. Okay, so this is n minus 1 P R minus 1. So the total number of ways where n distinct objects can be arranged so that one particular object is always included is given by n minus 1 P R minus 1. How many arrangements can be made out of the letters of the word brought? The vowels never being separated. Okay. Now, how many are there? Again, we have to do consonants and what are the consonants and what are the vowels? Now, what are the consonants? D is a consonant, R is a consonant, A is a vowel, U is a vowel, G is a consonant, H is a consonant, and T is a consonant. How many letters are there in the word drought? D, R, A, U, G, H, T. So 7 letters are there. Out of the 7, 5 are consonants and 2 are vowels. How many arrangements can be made out of the letters of the word? Okay, so I have D, R, G, H, and T. And I will always use the vowels together. A, U. Okay, so this is 1, 2, 3, 4, 5, and this is considered as 6. Okay, so there are 6 letters. Okay, so out of this 6, you have to make the arrangement. So this is 6P6, but this AU, I can write it as AU or UA. So what are the options here? 2 options. So into 2. So this is 2 into 6 factorial upon 0 factorial. So this is 2 into 6 factorial, which is equal to 2 into 720, which is equal to 1440. Okay. So take the alphabets, arrange them into consonant and vowels. See what the condition is here. The condition was that the vowels will never be separated. And for that, I can write these vowels as AU or UA. So what are the options? Two options are there. Either I can write it as AU or UA. So this is equal to 2. Okay, so we have discussed the theory part also. Yes, good. It is so nice to see that you are understanding. Very good. Yes, Zeba, Abhinav, Srinidhi, yes. Yes, good, Isha. Show that the number of ways in which n books can be arranged on a shelf so that the two particular books are not together. Okay, are not together. Then show that. This is a show that. You don't get show that sums. You will get an option. Which of these? Okay. Now, two books are not together. Remember the first sum that we did today is similar to this. Yes, are not together. Best and the worst paper. Remember that. Let me see. There is a question. Yes. 10 exam papers are arranged in such a way that the best and best papers are never coming together. So what we did here was we first found out how the 10 papers can be arranged without any restriction. That is T10 P10. That is 10 factorial. Now we put in the condition that these two papers are always together. We found out that value. That is 2 factorial into 9 factorial. And then we subtracted. We found no restriction. With this restriction, what we get is the arrangement of 10 papers such that the best and the worst papers are never together. Remember this? Similar to this, we have the sum now. Okay, the sum that we have just now is very similar to this. Okay. So, n books can be arranged on the shelf sorry for the spelling. Okay, it is SHELF. Okay. Yes, SHELF. So how much is this? NPN, which is equal to n factorial. Now, n books can be arranged such that two books are always together. So what will happen if two books are always together? What will happen? We will have 2, that is n minus 2, n minus 1, p, n minus 1. Because we have taken the two books together. So this is n minus 1 factorial into 2. Okay, into. Why? Because the two books can be arranged as, suppose the books are B1, B2, then I can write it as B1, B2, and the second option will be B2, B1. Okay. So I have n minus 1. Okay. N minus 1, P, n minus 1 into. So don't forget to multiply this 2. This 2 is very important because this books can be written as B1, B2 or B2, B1. Okay. So n minus 1, P, n minus 1 into 2. So this is nothing but 2 into n minus 1 factorial. Okay. So I want to subtract now. Okay. Therefore, number of ways in which n books can be arranged so that two books are not together, is equal to n factorial minus 2 into n minus 1 factorial. Okay. So this n factorial can be written as n into n minus 1 factorial minus 2 into n minus 1 factorial. I take this n minus 1 factorial common out. I take this n minus 1 factorial common out. And I get this is equal to n minus 1 factorial common out. What will remain is n minus 2. N from here and 2 from here. So this is equal to n minus 2 into n minus 1 factorial. Okay. So same thing you have to remember is first without restriction, then we am taking the restriction that they are always together. From the no restriction, if I subtract that they are always together, what do I get? I will get the condition when they are not together. Okay. From no restriction, if I subtract always together, I get not never together. Okay. This I have used. Okay. No restriction minus always together will give me never together. Okay. Understood till now? Yes, Zeba, understood? Okay. Vagdevi, why do we take n minus 1? See, suppose I had 6 books. Okay, suppose I had 6 books. Now what happened? This is book 1, book 2, book 3, book 4, book 5, and book 6. Now what I feel that B5 and B6 will always be together. Then what will I write? B1, B2, B3, B4, and I will put these two together, B5 and B6. Okay. Then how many books do I have? This will be book number 1, this will be book number 2, book number 3, book number 4, and these are taken together, so they will be considered as 5. So what is the difference between 6 and 5? Difference of 1. So instead, if this was n earlier, now what is 5? This is n minus 1. Okay. If n was 6, now it has become 5. So how can I write 5? 5 can be written as n minus 1. And that is why we have taken n minus 1 here. Okay. This n minus 1 is taken because of that. Hope you've understood. Yes, Zeba, I'm repeating that only. Yes. Yes, Pranita. Good, good. You've understood. Very nice. Okay. So, see, n books can be arranged in the shelf with no restriction in NPN ways. N books can be arranged with the restriction that the 2 books are always together is n minus 1p, n minus 2 into 2. Why this n to 2? Because of this. Either I can have B1, B2 or B2, B1. Okay. So that is the case. So 2 into n minus 1. Okay. And when I subtract from no restriction, I subtract this restriction, I will get the condition that the books are never together. So I have got this answer, that n minus 2 into n minus 1 factorial. Okay, Zeba, understood? Okay. Now next, there are 6 books on economics, 3 books on mathematics, and 2 on accountancy. In how many ways can these be placed on a shelf if the books of the same subject are to be kept together? Okay. Now, this is my shelf. And now what is the condition if the books of the same subject are always? What is the condition that books on the same subject are to be together? Okay. So this is my bookshelf. Okay, there are 3 sets of books. One set of books is of economics, one is on mathematics, and third is of accountancy. So this I have to place over there in the shelf. Now, what can happen is there are 3 places and 3 sets of books. So 3 places and 3 sets of books. So what will happen over here? These can be arranged in 3p3, which is equal to 3 factorial ways. Okay. 3 sets of books in 3 compartments can be arranged in 3p3 ways. But what happens is that economics, how many books do I have? 6. Mathematics 3 and accountancy 2. So 3 sets of books can be arranged in 3p3 ways, which is equal to 3 factorial. Now within that, within the set, within each set of books, we get, so this is equal to 3 factorial into economics 6 factorial, okay, 6p3 into 3p3 into 2p2. So answer is 3 factorial into 6p6, 3p3 and 2p2. So this is 3 factorial into 6 factorial into 3 factorial into 2 factorial. Because inside the set of books, there is no restriction. So that if I place over here economic books, so I will have E1, E2, E3, E4, E5 and E6. These can be arranged anyhow. So 6 books, 6 places, that is 6p6. Suppose I have accountancy here. So I will have A1, A2, or what is the other option? A2, A1. So in this, there are 2 places for the books of accounts and there are 2 books. So 2p2, so answer is 2. 2 factorial. Here I have mathematics, I have M1, M2, M3. So 3 books on mathematics and 3 places are there. So 3p3. 3. Okay, so this is the answer. How many 4-digit numbers can be formed out of the digits 1, 2, 3, 5, 7, 8, 9 if no digit is repeated? How many of these will be greater than 3000? See, here they have given the sum into 2 parts. One is no restriction. Second is a restriction on number the number which are greater than 3000. So how many digits are there? 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7 digits. And how many digits do they want? So, yeah. N is equal to 7. 1, 2, 3, 4, 5, 6, 7. How much is R? R is equal to 4. Okay, because it is a 4-digit number. So, number of 4-digit numbers is equal to 7p4, which is equal to 7 factorial upon 3 factorial, which is equal to 7 into 6 into 5 into 4. So this is how much? 20, 120, 840. Okay. 5 4s are 20, 22 26 are 120, 120 into 7 is 840. Okay. So there are 840 numbers that you can form with the given digits 1, 2, 3, 5, 7, 8, 9. Now they want which of them are greater than 3000. So what happens is 1, 2, 3, 4. This is the thousands place, right? Which numbers? Because it should be greater than 3. So I can have 3, 4, 5, 7, 8, 9. So numbers greater than 3000 is equal to, how much is this? 1, 2, 3, 4, 5, 6. What? How many options do you have? 6. 1, 2, 3, 5, 7, 8, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5. Oh, 4 is not there. 3, 5, 7, 8, 9. How many numbers are there? There are 5 numbers. Okay. So, for the first position, I have option of putting 3, 5, 7, 8, 9. So, how many options do you have? 5. Okay. What are the remaining? 1, 2, 3. Out 3 places are there. Okay. So, I've already used 1. So, what do I have? I will have 6p3. Okay. 6p3. How did this 5 come? Because how many numbers are there? 5 numbers. 5p1. 1, 2, 3, 4, 5. Out of 5, how many I am selecting? Only 1. So 5p1 into 6p3. 5p1 is 5 factorial upon 4 factorial and 6p3 is 6 factorial upon 3 factorial. How much is 5 upon 5 factorial upon 4 factorial? It is 5 and this is 6 into 5 into 4. So how much is this? 20 into 30, which is equal to 600. Six into 5 into 4. Oh, sorry, 6 into 5 into 4 into 7. 600, right? So, out of these 600 numbers are there which are more than 3000. Okay. Next example, there are 6 students of whom 2 are Indians 2 are Americans and the remaining 2 are Russians. Okay. They have to stand in a row for a photograph so that the 2 Indians are always together, Americans are together, and Russians are together. So what will happen? How many are there? 6 students. Which are the students? I1, I2, A1, A2, and R1, R2. Okay. And of these, you have to, what are the places? 1, 2, 3, 4, 5, 6. But these have to be together. This is 1, this is 2, and this is 3. So the places also have to be clubbed. I can have somebody like this, or together like this, or together like this. There is no other way. Why? Because all the students of one country will be together. So I have 3 places and 3 options. So I1, I2 together, A1, A2 together, and R1, R2 together. So 3 places are there and 3 sets of students is there. Okay. So 3 sets of students and 3, that is 3p3. How much is 3p3? How much is 3p3? Yes, can you tell me? Okay. Where is my this one? Just a minute, I'm not able to see my. Oh, yes, sorry. Yes. Okay, so I have these three sets of places and 3 sets of students. So how much will this be? 3p3. Okay, and 2 Indians can be arranged in 2 ways. 2 Americans can be arranged in 2 ways, and 2 Russians can be arranged in 2 ways. How much is 3p3? 3 factorial upon 0 factorial. That is 3 factorial into 2 into 2 into 2. How much is 3 factorial? 6 into 2 into 2 into 2 is 8. So there are 48 ways in which you can arrange students for a photograph in such a way that the students of one country will always be together. Okay. Okay. In how many ways can 8 people sit around a round table? Okay. We know that sitting around a round table is given by n minus 1 factorial. So this is 8 people. So 8 minus 1 factorial, which is equal to 7 factorial. In how many cases with 2 persons always sit together? So I had 8 people. So I had A1, A2 up to A7, A8. But now what they are saying is these 2 will always sit together. So how many people will remain? This is A1, A2 up to A. This is taken as 1%. So I have now n will be equal to 7. Here n was 8. Here n was 8. And now n is 7. So what do I have is 7. So now they will sit together. Sitting together will be equal to 7 minus 1 factorial, which is equal to 6 factorial. Okay. So when you want two person to always sit together, you have to treat them as one person, and in that these two people can sit together in two ways. Okay. So because they are sitting together, so that is 7 minus 1 factorial, and these two can interchange between them. So this is 6 factorial into 2. Yes, Rahul, very good. Very good. Where 4 is not given, Bhargavi, Masu? No, here see, how many 4-digit number is? 4-digit number means R is 4, right? So it is already given to you. When you are talking about 4-digit numbers, that means R is already given to you. Okay. Yes, very good, Zeba. Yes, Rahul, the answer is correct. Masum, what do you want me to explain? This sum? Okay. So this, see what, you have to pay attention to words in the word problems also. Okay. So here they are saying 8 people. So I know that my n is 8. But seated around a round table. This is very important because if I want to arrange them in a row, okay, when the people are standing in a photograph, then what will happen? The answer 8 factorial. But because I'm asking them to sit around a table, so what is happening? The formula for that is n minus 1 factorial. For circular permutation, the seating arrangement is done by n minus 1. In this case, this has been the first portion. The second portion is two particular person always sit together. So instead of 8, now what is happening? My n has become n minus 1. Okay, n has become n minus 1, which is equal to 7. Why minus 1? Because two people I'm considering them as 1. Okay, two people I'm considering them as 1. So this is n minus 1. Eighth sum, and then exercise. X and Y enter into a railway compartment. So what will be the answer? There are 6 vacant seats and 2 people. So 6p 2. So this is what will happen? 6 upon 4 factorial. So I will get as 5 into 6. That is 30 will be the answer. Okay. Okay. N is equal to n is equal to 6, r is equal to 2. So number of ways in which they can occupy is 6p2. So 6 factorial upon 4 factorial. So this is 6 into 5, which is equal to 30. Okay. The value of 10r RPR is r going from 1 to 10 is how much? Okay. So First, I will just show you by the expansion, because sometimes what happens is that you don't understand this summation sign. So I will just like to, this will also help you in the further sums also. So what does this mean is that a value of R is going from 1 to 10 and you have R into RPR. Okay. So I have R objects and I'm taking all those R objects. So let me put, so this, if I put 1, what will happen? This is equal to 1 into 1P1 plus 2 into 2P2 plus 3 into 3P3 plus 4 into 4P4 and so on. So I will have this to be equal to 10 into 10P 10. Okay. Now 1P1 is how much? 1. 2P2 is how much? 2P2. So let me show it over here. 2P2 is 2 factorial upon 2 minus 0 factorial, which is equal to 2 factorial. Okay. So 2P2 will be 2 into 2 factorial plus 3 into 3 factorial plus 4 into 4 factorial and so on and so forth up to 10 into 10. Okay. This is the expansion. This is the expansion of the summation R going from 1 to 10 R into RPR. Now what will happen here? What is going to happen over here is NPR plus NP N minus 1 PR. NPR plus okay, so we will do this. So how much will this be? Remember the formula? NPR yes, can you tell me? I mean, put it in the full form. Have you understood this summation? Just let me know first. Okay, why is it this confusion over there? Okay, okay, fine. See, just let me explain this again. This is just summation, you know, there is nothing big about it. Just let me. Okay. Just let me write it here. It's not, the board is not cleaning up. So I have summation. Summation means that I'm adding different. This sign is for summation. It means I'm going from one number to another number. What is the number? R is going from 1 to 10. R is going from 1 to 10. So that whatever is there inside the summation, I will change the value of R. So R is going from R into R, P, R. This is given to me. Now what this means is, first I will put the value of R as 1. Then I will put it as 2. Then I will put it as 3. And till where will I go? This upper limit. This upper limit. Till here I will go. What is the upper limit? 10. So this is equal to 1 P1 plus 2 into 2 P2 into 3 P3 plus, plus, because it's a summation sign. So every time I change the value of R, I will write a plus sign. Plus 4 into 4P4 and up to 10 into 10P10. This is the meaning of this. Okay. Now what happens is, what is this? This is equal to 1 into 2 factorial plus 3, because 2P2 I know the formula. NPN is equal to N factorial. This is 3 into 3 factorial plus 4 into 4 factorial plus so on plus 10 into 10 factorial. Now what happens here is that I have to club them. Okay, let me take up this because it's already past your time. So it doesn't matter. I will take the sum tomorrow completely, so that once, I hope you've understood the summation condition. Okay, just let me know whether you have understood the summation concept, and then tomorrow we are going, because it will involve a lot of steps, and I will show you how you have to rearrange them and you will get the answer. Okay, don't worry, we will be doing this sum next time also. Okay. Yes. Okay. Have you understood now the concept of summation? Sakshi? Yes, Radhika, I know it is already 4 p.m. Yeah. Okay. Yes, Rohan. Thank you so much that you've understood. So let us stop here. Here for today. I will take the sum next time. The whole sum we will take it up. Okay. Yes. Thank you for your patient hearing. Have a wonderful day ahead. Thank you. Tech support. Yes.